Hello everyone. This video is about some calculations for our project, for our design requirements for railway, which we are designing in our classes. And as you may see, I prepare some Excel, some Excel with some calculations. And as you may see, it is connected with transferring some requirements to our calculations from the EN standards. And as you may see, we must put some data and check if all parameters of our railway, especially the parameters of the horizontal alignment, is correct. So first of all, we must assume some data about the maximum speed and minimum speed. So the speed passenger trains will be maybe 120. So the speed for the freight trains will be, I don't know, maybe 70 kilometers per hour. Then we must assume some value of the count. Maybe it would be good to assume that the candle will be about, I don't know, maybe 35 millimeters, and the radius for our circular curve can be about, I don't know, 1,750 meters. And as you may see, down below we have some conditions for our parameters, the minimum radius, which is about 150 meters. And here we have the condition in Excel, which check if all parameters are correct. As you may see, the radius is okay. And down below, we have two requirements for our count. The minimum value, which is 20 millimeters, and the maximum value, which is 160 millimeters. All of them, these two conditions is correct, yes. So our count is assumed correctly. And then we must calculate two main parameters, the count deficiency and the count excess. As you may see, here are the formulas for the both parameters, and they are transferred to these Excel cells. Yes, the count deficiency and count excess. And as you may see, there is also the conditions for the maximum count deficiency and maximum count excess. Yes, you may see 110 millimeters. Oh, sorry. So here, 110 millimeters for the count excess, and so here 153 millimeters for count deficiency. Oh, sorry. Okay, so as you may see, our pair of the count and the radius, it is assumed correctly, and this cells set us also it is good. Yes, the count deficiency is okay, and the count excess is also okay. You can play with some values, and you can see how the parameters are changed. Yes, as you put some other values of the radius and count, the parameters of the count efficiency and the count excess are also changed. And you may see which values of the radius maybe is not good or big. As you may see in this pair of count 160 millimeters and the radius value of 5,000 meters are not good for our example, for our calculations. Okay, so let's back for our initial values, our pair. So by the count of 35 millimeters and radius by 1,750 meters, the count deficiency and count excess are good, are proper. So now we must assume some parameters of the transition curve, the parameter, and as I show you in the example in the other video, let's assume the 100 meter, and we can see how the current gradient is calculated. Here, so in this cell, we have the formula for current gradient, and that is not something sophisticated. Only one parameter is divided by second one. The change of the count is, in our case, so the value of our count, and the change of the length as the change of our transition curve is only the value of this parameter. So when our gradient is calculated, we must also check if it is correct. And here you see the condition which said if our gradient is correct. The maximum value for our gradient is 2.5 millimeters per meter. And the value which I calculate is correct. So the all calculations are done. It's quite simple, I think. And when we do everything, the whole calculations, yes, this whole way down, we assume that our circular curve parameters are radius with the 1,750 meters and the count value of 35 millimeters. And if we have few circular curves in our project, we must done the calculations for everyone. So that's all about the horizontal alignments. We must calculate the part of the radius and the count for every circular curve in our project. Thank you very much. That's all for me. If you have any questions, please ask freely.